Very good morning to one and all once again. So we are moving on to second lecture of module number 6. So in this module we are going to discuss about two important manufacturing process. They are sandcasting and forging. So when you if you look at this picture, maybe many of you have seen this kind of picture, isn't it? What is in this picture represents? Some person they are pouring they have a molten metal in a ladle, and they are pouring this molten metal from the ladle to the mold cavity and making the casting, isn't it? So it's many of you have seen this picture. So this is a very small simple picture to demonstrate the casting process. Then if you come to the sand casting, the sand molds, you need a sand mold. So that is the highlight of a sand casting, which means you are doing this casting with the help of a sand mold. That is sand casting. Casting with the help of sand mold. You are pouring the molten metal into the sand mold. The mold cavity created by the sand. Okay, that's called a sand casting. So as I told you, the sand molds, you need how to prepare the sand mold. That is the important step in a sand casting. The sand molds are prepared in a specially made box called a molding box or molding flask. Yeah, you have seen this kind of box in your workshop, isn't it? A top part, a bottom part, cop drag. I hope you remember. So the sand molds are prepared in a specially made box called a molding box or molding flask. I hope you are remembering, isn't it? These two parts are aligned using pins, etc. Okay. Usually, some metallic uh, uh, molding flask are used in your while you are doing these sand molding process in your lab. Now, another important uh, nomenclature associated with the sand casting process is the gating system. So, what is a gating system? Yeah, it's a passage for bringing the molten metal to the mold cavity. When you pour the molten metal, it passes through a series of regions and finally it reaches the mold cavity. So the passage of bringing the molten metal to the mold cavity is known as a gating system. So if you look at the picture, this is actually complete ഒരു സാൻഡ് മോൾഡ് എല്ലാം പ്രിപ്പയർ ചെയ്ത് കഴിഞ്ഞ് അതിൻ്റെ റൈസറും എല്ലാം അതിൽ കട്ട് ചെയ്തതിന് ശേഷമുള്ള ഒരു ക്രോസ് സെക്ഷണൽ വ്യൂ ആണിത്. A sectional view of a sand mold ആണ് ഇവിടെ കാണിച്ചിരിക്കുന്നത്. So here this gating system, where is this gating system? Starting from this pouring basin. Pouring basin എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്തായിരിക്കും? So actually the actual pouring takes place to this part, and through which the molten metal pass through and it finally reaches this mold cavity. Okay. So it consists of a pouring basin, a sprue, and a gate. So this small region is called a gate. So the pouring basin, which is actually cut at the or made at the top of the mold. So what is the function of the pouring basin is to help to maintain the required rate of flow of molten metal to the mold cavity. So that is the function of the pouring basin. So finally, when you pour the molten metal, so it comes here in contact and it allows the molten metal to pass through it. So the main function of the pouring basin is to help to maintain a required rate of flow of the molten metal. So it also prevents the slag from entering into the mold cavity. And if you look at the sprue is a vertical passage that passes through the cob. This top part, this molding box in the top part, and I told you, it's known as the cob, and the bottom portion is called the drag. You know about it, isn't it? So the sprue is a vertical passage that passes through the cope. This is a cope region and connects the pouring basin with the gate. So the gate in a pouring basin had to connect in a vertical passage on a sprue. And then what is gate? It's a passage through which the molten metal flows from the sprue base to the mold cavity. This is a sprue base, and from the sprue base, the gate which connects the mold cavity with the sprue base. Okay. Then what is a riser? The passage made in the cope to permit the molten metal to flow after the mold cavity is filled with it. അതായത് once the molten metal entered in the mold cavity, is if some excess metal is required, the riser feeds this extra metal in order to prevent some kind of shrinkage defects. Okay, so the riser acts as a reservoir and feed molten metal to the mold cavity to compensate for the solidification shrinkage of castings. Okay, and again, this riser also acts as a vent for what? For steam and gases generated in the mold cavity. Okay, it acts as a vent to escape, helps to escape the gases and the steam which is formed during the pouring of the molten metal into the mold cavity. Then what another important part would be the core. I told you before core. It's actually if you want to make a hollow casting, we need an extra pattern called a core. So it's a prepared solid mass of dry sand having the shape of the internal cavity or the hole in the casting. So when you keep a core like this, when you pour the molten metal, wherever you put the core, so that part will not be filled with the molten metal. As a result, a hollow region will be formed in that part. So again, these cores are prepared separately using core boxes and are kept in the mold after the pattern is removed. Okay, and again, sometimes these cores are also known as core prints, P-R-I-N-T-S, core prints. So because if you want to obtain, sometimes this core is inbuilt with the pattern itself, and the projection of the pattern intended to get the impression in the mold which support and hold the cores. It's called the core prints. So I'm sorry. So I have a what I trying to say tell you is the core print helps to hold the core in the mold cavity. The core prints which helps to support the core in the mold cavity. Now let's see how the molding is made. So this is actually a three-dimensional view of a mm, mold cavity, and you can see that you will get a better clarity of what do you mean by a pouring basin, sprue, what is gate is all about, what is a gate, sprue, well, and what is mold cavity, what is core sand, everything you can see it in this picture. Now we are going to move to a very important step. So it's called the two box molding. So this process you have done during your workshop. So the theory part which I am going to explain will be easy for you. Yeah, you know that there are two parts. One is the bottom half of the box. A molding box is required for making this molding, isn't it? So we are going to discuss the molding procedure now. So the bottom half of the box, എന്തായിരുന്നു പറഞ്ഞത്, drag, and the upper half is called the cope. Let's see the procedure. Now, first procedure would be the bottom half, that is a drag, which is placed upside down. That is shown here in this picture. The bottom half is placed, or the drag is placed upside down over a molding board. You can see the bottom board here, and you placed the bottom half upside down. That is a drag part over a flat plate. So this bottom, okay, you can see it. Now the bottom half of the pattern is now placed over the molding board at the center of the molding box. You can see this is the bottom half of the pattern, which is now placed over the molding board. That is a flat plate. You can see it here at the center of the molding box. Now what would we do next? Now you sprinkle some molding sand over the molding board and the pattern. This sand is called the parting sand. Okay, you know that. So the dry molding sand or the parting sand is sprinkled over the molding board and the pattern. Now the box is molding box, that is the bottom part, drag part, is filled with the previously prepared molding sand. Molding sand which fill and then what you will do next? The sand is slightly rammed to fill entire space in the molding box. Ramming. Along with ramming, the sand is packed completely in the box. So that is what is you can see. This is a pattern. You can see that the sand is filled completely and rammed. Now excess sand is removed by scraping with a flat bar. You know that. Okay. Then what you will do? Then now the molding box is turned upside down. You can see. Look at this. Okay. So this was like this, and you turned it upside down. Now the cope part of the pattern is placed above the drag part of the pattern. Look at this. Cope part of the pattern placed over the drag part of the pattern. Now what you will do? Now the top half molding box, that is a cope, is placed above the sand filled the drag part. Now you will get it over here. You can see this. Okay. The cope part of the top half molding box is placed above the sand filled drag part. Now you, with the help of aligning pins, the aligning pins in the drag are linked to the corresponding lugs in the cope part. This is called the lug, this is called the pins. Okay. And then a riser and screw is placed, or what you will do? You know that. Okay. The riser pin and the screw pin are placed. Then, keeping the pins in position, the cope is filled with the molding sand. Riserum screw pinum vechadinu sheshamayirikkanam you have to fill the top molding box, that is cope, with the molding sand. Then after ramming and making it well, the screw and riser pins are removed after slightly shaking the pins. You remove the both screw and riser pins. The cope is now removed from the position and kept upside down over the table. I mean this part. Okay, upside down. And both half of the pattern can be, that is the pattern from the drag and the pattern from the cope, can be easily removed from the mold by slightly shaking and lifting it out. So on the open surface of the drag, a passage is cut to connect the bottom of the screw to the mold cavity gate. There is a gate we discussed just before. Okay, you know that how it can be cut. So where it is done, on the open surface of the drag, a passage is cut to connect the bottom of the screw to the mold cavity. That is that. Okay, now the mold cavity is ready for pouring the molten metal into the mold. So this is the two-box molding process. നമ്മളിപ്പോൾ പഠിച്ചത് വളരെ important ആയിട്ടുള്ള ഒരു manufacturing process ആണ്. It's called casting, and here we discussed about the sand casting, and then the important step in sand casting is called the sand molding. Okay. Now we are going to discuss about another important um, manufacturing process called forging. Called the forging. What do you mean by forging? Where you hear about the forging? Yes, the forging is a metal forming process. Have you done a metal forming process in your basic mechanical workshop? Yes. Have you remembering the blacksmithy operation you have done? Same thing. You are heating the metal to some temperature. Sometimes we will do it at room temperature itself, and you are shaping it. So the forging is a metal. So it comes under the forging technique, the blacksmithing. Okay, so the forging is a metal forming process in which the workpiece is shaped by compressive forces. You are hammering it using some hammer, maybe using with the help of some machines. Okay, so it's a metal forming process in which the workpiece is shaped by compressive forces applied through various dies and tooling. So forging is a metal forming process through the application of compressive stress for deformation. So it's actually one of the oldest and most important metalworking operation, and dating back at least to 4000 BC. This process was used. The forging was forging first was used to make jewelry, coins, weapons, etc. by hammering the metal with tools made up of stone. And it can, as I told you, it is carried out either hot or cold condition, but it's generally a hot working process. Okay, as I told you, in this process the work material is heated and a force is applied either by impact or by applying a gradual loading to deform the material to the required shape and size. Okay, now you can see some of the forged parts. What is shown in this picture are all made using a forging process. Okay, large rotors for turbines, gears, bolts, you can see rivets, hand tools, numerous structural components for machinery, aircraft, and air railroads. So all these parts are made using the forging technique. Now, when you discuss about this forging, so rolling is another important metal forming operation, which means the work material is filled between two rollers, and you are reducing the size. So unlike rolling operations, so actually the rolling operation which produces continuous plates, sheets or strips. Okay, unlike this rolling, the forging operations produces discrete parts. And again, this forging may be carried out at room temperature, it's called cold forging, and when it is carried out at high temperature, it's called the hot forging. Now, what are the advantages of using forging? You will get close dimensional accuracies can be achieved using this manufacturing technique, which means it requires very little machining after the forging is done. Higher strength can be achieved, greater productivity, and again, the grains. The grains means the structure which is you can observe using a microscope or a granular structure. The, the grains or the crystal, the favorable grain orientation and high degree of surface finish can be obtained using the forging technique. Now the forging can be classified mainly based on three factors. One is working temperature, forging equipments, and forging constraints. What is based on working temperature? Hot forging and cold forging. At elevated temperature or room temperature. Elevated temperature we will call it as hot forging, and if it is at room temperature, we will call it as cold forging or warm forging. And based on the forging equipments, sometimes if you are doing it with the hand, you will call it as a hand forging, and with the help of machineries, you will call it as a power forging. Okay, we call it as a power forging. So a hand forging, which you have done during your blacksmithy operation. It's a manual forging. Actually, it is used only for small parts and made in small quantities. Whereas the power forging is the most common, which is used in industries, used for large scale manufacture of small to very large components. Actually, in the case in this manual forging, impact pressure is applied to the workpiece by way of hammering. You have done the impact pressure using the hammer. Hope you are remembering. Okay, so that's why the manual forging is also known as Smith forging. Smith forging. However, a machine that applies an impact load is called a forging hammer. Um, I'm sorry. In this case, the machine that applies an impact load is called the forging hammer, while the machine that applies gradual pressure is called the forging press. So, based on the equipment, you can classify it hand forging and power forging. And based on the constraints to metal flow, it can be classified into again three. So actually, this classification is based on the constraint imposed to the flow of work metal by the dies. So actually, the die means dies are the parts of forging machine between which the work material is squeezed to deform as per the contour of the dies. So you can classify it as open die forging, closed die forging. So based on the constraints to metal flow. So for example, in open die forging, so the first top two pictures shows the open die forging, which means the workpiece is placed between two flat dies. So these are the dies. This is a die, this is a die, this is a die, this is a die. Okay, the workpiece is placed between the two flat dies, allowing the metal to flow freely without any constraint along lateral direction. You can see that in this direction there is no constraints, only the constraint in this direction. So that's called open die forging. And similarly, you can see the last picture. If you look at the last picture, that is an example of a closed die forging. The die surfaces are shaped according to the required contour of the final product of forging. Here, the work material is constrained to flow as per the shape of the dies. Okay. So, another important term associated with this, when you are doing this forging operation, you can see that when you are applying the compressive load using the die, some excess material come out from the dies, and these are known as the flash. These are known as the flash. Now let's familiar with some of the basic operations used in a forging. Let's familiar with some of the basic operations. One is the upsetting. What would be an upsetting? Upsetting means so this is what you sometimes you have done during your workshop. Process applied to increase the cross-sectional area at the expense of its length, which means the length gets reduced whereas the cross-sectional area gets increased. You can see how the hammer is done. You can see the anvil, you can see the bar, which we are going to increase the cross-section and to reduce the length with the help of hammer applying the compressive load. So this is called the upsetting operation. Sometimes this is also known as jumping or heading, upsetting. And the second operation is called the drawing down. Drawing down, which means operation just opposite to upsetting, which means the length is increased at the expense of its width or thickness or both, which means the force is applied perpendicular to the length direction of the component. This is also called the drawing out. Okay, so the picture which you have രണ്ടാമത് കാണിച്ചേക്കുന്ന ഈ picture, the colorful one, you can easily understand. You can see that you see the workpiece. The workpiece is holded with the help of a tongue, and you keep it on the anvil and you are hammering it in this direction. You can see that sometimes the length gets increased, increase in length, decrease in thickness and width. Okay, that's called a drawing down or drawing out. Another important operation is called the flattening. So actually the workpiece you got after the drawing down or drawing out, will have some kind of marks left on the surface, and these are leveled off by the flattening operation. You can see that you will flat with the help of a flatter, the undulations on the surface of the metal will be leveled off. Okay, which means the marks are leveled off by flattening operation, the flattening tool. So another important operation is called the fullering. You can see that the picture easily will give you a understanding of what is meant by a fullering. Process of reducing the cross-sectional area of the portion of a workpiece. Okay, process of reducing the cross-sectional area of the portion of a workpiece is called the fullering. And again, here also maybe something like similar to an drawing down operation. However, the machinery is used is different. Here also the length of the workpiece is increased through an outward metal flow. Okay, you will use a tool called the fuller. So this is called the fuller. This tool is called the fuller. You can see that with the help of a tongs, you placed the work material in between the fuller, and you are either with the help of a hammer or some another operator. With the help of a hammer, you reduce the cross section here, and it also increases the length in this direction. Fullering and the edging. So the edging is used to shape the ends of the bar by concentrating the metal at the ends. You can see that if you want to get a structure like this is the final shape. If you want to at one end you want to get a shape like this, you you will keep the metal bar like this, and you will apply a compressive load so that the metal get concentrated in this region. So edging is used to shape the ends of the bars by concentrating metal at the ends. Usually you will use concave shaped open dies are used for this. Concave shaped open dies are used for this. And another important operation called swaging. It's actually a finishing process to convert the bar stock to a final dimension and cross-sectional shape like round, square or hexagonal depending upon the shape of the die. Another important operation called the bending. Yes. So if you want to get an angular or curvilinear bend surfaces, you will go for this operation. So the angular and curvilinear bending can be carried out using forging. Actually, if you are going to do a hand forging, the edge of the anvil is used to develop a curvilinear bend on a bar stock. Okay, you can see how the bending is done using this picture. And punching. What would be the punching? So it refers to the operation in which the punch is forced through a workpiece to create a hole. Okay, which means the hot workpiece is usually placed over the anvil surface, and punching creates a hole by removing some metal from it. So removing this metal. Okay. Another is piercing, which means the process of making an indentation on the hot workpiece. Here no material is cut or removed from the workpiece. Punching, the material is removed, whereas in the case of piercing, no material is removed. We are making an indentation. So these are some of the basic forging operations. Now let's see different type of forging methods. One is called the Smith forging, and then power forging, drop forging, and press forging. Let's also look into it. What do you mean by Smith forging? Smith forging is nothing but the operation which you have done in your blacksmithing. That's why it's called a blacksmithing. Okay, the Smith forging involves you are heating the workpiece in a blacksmith furnace. Why it's called a blacksmithing? Using the furnace which you are using is known as the blacksmith furnace. So the smithing for Smith forging involves heating the workpiece in a blacksmith furnace and hammering it over the hammering the workpiece over the surface of the anvil. So that's called the Hand forging or smith forging, actually this is a traditional forging operation. Okay, to get the required shape, the operator has to manipulate the component between the blows. So which means, again, the smith forging needs skilled operators, because the operator must know how to select the suitable tool and operation to manipulate the workpiece to attain the final shape. Like the forging operations like upsetting, drawing out, fullering, flattening, venting, etc. are used by the operator to carry out the work. Actually, it's a time-consuming process, but still economical for some small-scale production. Another important operation is called the power forging. What would be power forging? All power-assisted forging methods are commonly called a power forging, which means we are not doing by hand. With the help of, we will use some kind of machinery, or all power-assisted forging methods are commonly called as power forging. Okay. The smith forging you have done, that is a hand forging. It's suitable for small work pieces only. Okay. If you are going to use a forging machine, forging machines are designed to shape a hot workpiece by a forging action. The forging machines are suitable for large workpieces to have made in larger quantities. Okay. Power forging. And then, another important operation is called the drop forging. So what would be in the case of drop forging, repeated hammering is used to shape the workpiece as per the shape of the cavity. We will do repeated hammering, which means this operation is done in a closed impression die, and the force for shaping the component is applied in a series of blows by using drop hammers. Okay, so few products made by drop forging include crane hook, wrench, crankshaft, etc. are some of the products made using drop forging. This process is suitable for mass production of small and medium-sized products. Another important operation is called the press forging. So actually this process is similar to drop forging, but the method of application of force is different. Instead of a series of blows as in the case of drop forging, here the metal is shaped by means of a single continuous squeezing action. That's the peculiarity of a press forging. The metal is shaped by means of a single continuous squeezing action between the dies. So how the squeezing action is done? Either by using a mechanical loading or by using hydraulic means. The squeezing is obtained by pressing action by hydraulic or mechanical means. Hydraulic presses are used for heavy work, and whereas the mechanical work is used for lighter work. Again, this press forging is suitable even for complex shape with internal cavities. So these are some of the differences between a press forging and a drop forging. So the press forging is a slow process, whereas the drop forging is a fast process. No restriction in the size of the component, whereas the limitation on size of the component associated with the drop forging. The life of presses and dies is more in the case of press forging, whereas the life of hammers and dies is less. Lesser vibration and noise in press forging, more vibration and noise in drop forging. Semi-skilled operator is required, only is sufficient for press forging, whereas the drop forging requires highly skilled operator. You can make complex shape with the dimensional accuracy, but the dimensional accuracy in drop forging is limited. Die alignment is easier in the case of press forging, whereas the drop forging die alignment is difficult. So these are some of the differences between a press forging and drop forging. So the power forging is also known as machine forging. Sometimes in some of your book it is, because we are using a forging machine. So that's why it's called a power forging or machine forging. Okay. So that's all about. Thank you.